Okay, so thank you and congratulations for attending a talk this late in the evening about web application security. So we're going to cover a lot of material today. You're going to see a lot of links on the slides. Thankfully, you can download the slides with a PDF. You get a PDF with all the links in there. Because security is a really broad field, and I'm trying to cover a lot of topics. Many of those topics could be the subject of their own one-hour talks, right? So I'm going to give you the resources you need, to dig deeper later on, all right? So the slides are there. Feel free to get them at any time. So let's look at software first. Software is everywhere. It's pretty scary, right? If you think about it, every aspect of our lives are driven by software, right? You got banking, healthcare, finance, travel, entertainment, communications, home automation. This is where it gets personal, right? In your home, you have a lot of software that runs. Your alarm systems, fire detection, surveillance, in the military as well. And of course, software also drives cars these days, right? Tesla is famously doing a lot of really cool experiments, with their cars. And of course, you might ask yourself, what could possibly go wrong? I don't know, how about a Tesla crashing at a Tesla dealership, right? Or how about you're driving your car one day and then some hackers figure that they could drive your car better for you, right? And kind of break it. So that was in 2015. And then in 2016, they did a repeat of it. So Jeep cannot catch a break, right? So as you can imagine, InfoSec is a real big pain. And we can look at our whole exposure, right? If you start with your business and you have some data in your business, hopefully you've done the right thing, and we're going to touch that at the end, but that data lives in its own isolated cloud network that's private. You may have some internal applications, such as an inventory management application or a client relationship management like a CRM system, and that's kind of internal. It's not outward facing. And to give access to these applications, you may have a VPN such that your employees can go into the VPN and then they can access those internal applications, right? And that's kind of one entry point into your business data. The other big entry point, obviously, it could be your marketing website on the right, right? It could be your portal application, your software as a service, app.yourbusiness.com. It could be an API, right? All these things can also interact with your business data. And where things get scary, obviously, is for those things on the right, we're going to expose them to the outside world, right? We're going to open port 80 and port 443 such that end users can interact with our applications, which interact with our data, right? So then things get interesting. So if I'm an attacker and I want to own your business, I'm going to do some spear phishing campaigns at your employees, try to get some malware onto their computer so that I can hack into their VPN and then break into your network, right? That's one way to do it. But where things get very juicy for me is I see that you're running all those web applications exposed to the outside world, right? So I'm going to get in there, because I know that you're running some old version of WordPress. I know you haven't patched your, site. I know it's going to have some vulnerabilities, so I'm going to try to get in there. And that's kind of what we're going to look at today, kind of this right here, right? The web application security. That's one big risk, one big exposure into your business. So let's look at some security breaches. So if you want to get very depressed, you can read these articles on your own time. They kind of document some of the most famous high-profile hacks. But these are all the things that you hear about, where you got millions of records being compromised, right? You have dozens of those every year. But you have a longer tail of smaller businesses getting owned all the time, right? And you don't hear about them, right? And that's us, basically, right? And that's what makes things very scary. So you can look at these articles on your own time. But let's look at some high-profile breaches, right? You may all have heard of this company called Yahoo. I don't know, been around for a little bit. So through some advanced spear phishing and exploiting an internal web application of theirs, they leaked 3 billion accounts right before they were going to be acquired by Verizon. And that knocked down their purchase price by a lot. In the US, there's an agency called the Office of Personnel Management. And they keep sensitive personal information about government employees. They got hacked pretty badly, and they exposed 9 million government employee records. It's devastating for many decades in the future. It's really terrible. Now, the one that angers me the most is Equifax, because while Yahoo and OPM were not pure web application hacks, Equifax was literally compromised through one of OWASP's literally top 10 documented vulnerabilities, which is an insecure component. They were using an outdated version of the Struts templating engine, and through that, 143 million customers, US citizens with all their social security number, personal life information got hacked. It's devastating. It really hurt us in the US. So these are some of the high-profile hacks. There are a lot more of them, right? So what makes web applications juicy, right? What makes them an attractive target to hackers? Well, there are millions of them. It's really easy to do, right? It's really easy to script the scanning for vulnerabilities. There are many open source tools to do it, right? So hackers can just use that and modify them a little bit. They have access to a lot of sensitive information. And it's a large attack surface. I mean, there's the web application itself, but there's also the servers, the operating systems. And we're going to look at some better practices there. But yeah, the attack surface is pretty massive. And then there's this thing called denial of service. I have a whole other talk on that specific topic, which I'm not going to get into. It's not in the scope of this. But basically, it's very easy for anybody to take any site down, right? It's like, beyond having access to a botnet, most sites are very vulnerable to just being shut down. So anyway, how do we protect ourselves? How do we improve our posture? We're going to look at a number of strategies. And nothing is foolproof, right? We have to be right 100% of the time. They have to be right just once and then own us, right? So to me, the most important thing is to educate ourselves, especially software engineers, right? You hear a lot about DevOps and DevSecOps, and that's great, right? But we as software engineers, we're going to be the ones introducing those security vulnerabilities, okay? It is absolutely critically important that we educate ourselves on what they are and how to prevent them. So first thing is educating humans. Then there's, code reviews, right? It's humans reviewing other humans. Then we start involving the machine. We have automated code scanning. So if any of you attended Victoria's session the hour before, she showed a lot of really cool tools in the Azure ecosystem. And we're going to look at some other open source tools today. But static analysis of your code is a very useful tool. Beyond our own code, we also reference a lot of libraries, third-party open source libraries. Those have a lot of vulnerabilities. We need to know about them. And we're going to look at a lot of really good tools that allow you to find those that are vulnerable. Then you have automated penetration tests. So once your code is deployed somewhere, you're going to try and do what a hacker would do from the outside. Last resort, you have a web application firewall. We're going to touch on that a little bit briefly, but I'm not a fan of those because false positives are a thing, so we're going to look at those. And then you also do have logging. It's good to log things that happen in your system. because when someone owns you, it helps you figure out what happened, right? So we're going to look at the things in bold in this presentation. But I do like to draw a red line. Actually, I meant to have it one above, just above automated penetration tests, because I really want to catch vulnerabilities before they get deployed, even to a staging server, and definitely before going to production, right? Because then things get a lot more expensive. But all right, let's look at educating humans. When it comes to educating humans, one organization stands above all, and it's called OWASP, the Open Web Application Security Project. They look at things as approaching application security as a people, process, and technology. Cool? So they have a lot of good resources, and we're going to reference them a lot in this presentation. So every couple years, they publish a paper called the OWASP Top 10. It's a list of top 10 vulnerabilities, and you can find it here. All right, so we're going to come back to those, but right now let's look at tooling. Okay, so that's the list we looked at. Here I have the red line in the right place. Okay. Let's first look at automated code scanning. So on this web address, OWASP has documented a lot of open source and commercial static analysis tools, right? So I'm going to touch on a number of stacks. If your stack is not in there, you will find it in there, right? They really do a great job of covering a lot of technology stacks. So in PHP, there's these projects that we can use. We've been using Sonar PHP. So Sonar Source is a pluggable architecture for static code analysis. And they have plugins for almost every language. Okay. Now, OWASP did build their own static analyzer for PHP, and it's at this URL. All right, so if you're into Ruby, you got these guys here. Again, there's a Sonar plugin for Ruby. If you're into Python, there's Bandit, and again, Sonar Python. And if you're into JavaScript, there is a Sonar.js plugin as well for Sonar Source. I could not find any other project that did just pure static analysis for JavaScript. If you know of one, find me after the presentation. Okay, so that was that. Now we're going to look at dependency vulnerability checks, which means our code references third-party code, which may have its own vulnerabilities. Right? So there are tools to help us catch those vulnerable third-party packages. So the OWASP project has created a platform that covers many languages. It's called the OWASP Dependency Check. You can use that if you want. They cover Java and C# out of the box with very solid experimental support for Ruby, Node, Python, and PHP. Okay? And in PHP, there are a couple more projects. One that you can use for only new packages that you introduce in your system, so it's faster. And the other one allows you to, you can use it to look at all the packages you've already referenced, right? So if the first time you do it, it's good to use that second one. So, and in JavaScript, there's the Retire.js project. Highly recommend it, because NPM has a lot of packages, and it's very active. So it's really good to use this product here. All right, so that was for dependency vulnerability checks. Now we're going to move below the red line. Okay, so hopefully you've caught everything before, but things are going to leak. So automated penetration tests. OWASP actually has two of them. So Victoria showed us the Z-attack proxy in the previous presentation. They have one called OWTF. It does not stand for what you may think it stands. offensive web testing framework. Okay? All right. It's not me, it's them, okay? And they also have the Z attack proxy, right? So, I recommend using those tools. And of course, you have an oldie but goodie. It's called Metasploit, right? So there's an open source version of it. It's made by Rapid7. But Metasploit will test a lot more than your web applications, right? It's going to test all the open ports on your network, and it's going to try to own all your systems in very exotic ways. It's also a really good tool. And they do also support web application vulnerability. So these are all good tools, and they're free. Okay, so now that we've looked at pen testing, let's say we are in production and we want to have one last line of defense. A web application firewall is usually software that can stand in front of your web server. It could be like a load balancing proxy, for example. It can also be a plugin to your web server as well, right? There are different ways that you can deploy one. But of course, what I like to say is beware. There are a lot of false positives that happen with web application firewalls. And when that happens, you're blocking valid traffic. And in my experience, it's been a big problem when you run a site, let's say it's a forum site with a lot of user-generated content. A blog with comments, right? Be careful, do a lot of testing, and do the proper tuning if you're using a WAF. So there are a number of open source ones. Mod Security is the most famous one. And then there are things that you can plug into Nginx. You got Resty, you got Naxi, and then you got ShadowD as well. So, feel free to try those, but again, be careful, okay? You do not want to block legitimate traffic. That's a good way to anger your users. You do not want to see them angry. Okay, so that was for tooling web application firewall. And this concludes the tool section. Now we're gonna get back to educating ourselves about what those vulnerabilities are, right? Because in the end, we're gonna write a lot of code, and we need to not introduce those vulnerabilities. So let's go back to educating humans. So when it comes to vulnerabilities, there are a lot of possible ones. I'm gonna go over the ones that I come across all the time that are recommended by OWASP. And I look at them in two classes: low-level vulnerabilities and application vulnerabilities. So let's start with low-level vulnerabilities. In that category, I look at injection vulnerabilities, which includes SQL injection, NoSQL injection. We're also going to look at ORM NoSQL injections, okay? Also within injection, there's cross-site scripting vulnerabilities. And now there's also another type of vulnerability that's low level, which is cross-site request forgery. Okay, so we're going to explore those. Okay, so here's SQL injection. Have you guys ever seen this cartoon? You have, right? Hi, this is your son's school. We're having some computer trouble. Oh dear, did he break something? Well, in a way. Did you really name your son Robert, quote, parentheses, semicolon, drop table students? Oh yes, little Bobby Tables, we call him. Well, we lost this year's student records. I hope you're happy, and I hope you've learned to sanitize your database inputs. Right? Pretty famous cartoon that's been around for a long time. So SQL injection has many impacts. It can leak data. It can destroy data. Overwrite it, insert it. It's pretty much ownership of the database at this point. You can escalate user privileges within an application, by modifying a few database records. So the vector is pretty simple, okay? When you have an SQL string and you insert a variable in it, and that variable can come from an HTTP request, then you will get owned. It's just a matter of time, okay? So when it comes to mitigation of a SQL injection, you always hear sanitize your inputs. I say no. I mean, sure, do sanitize your inputs, but what really matters is to use prepared statements. That's what matters the most. Okay, every relational database system out there, every language supports prepared statements. Okay, with the name parameter binding. So the way it looks like this. You have a SQL string, and where the dynamic data goes, you give it a name with colon. So colon ID. That's it, right? So OWASP has a cheat sheet on how to do this in literally every programming language. So you can reference it for your stack. But yes, and like I said, input sanitation is okay, but it's brittle. And it's not sufficient. So the way it looks like, it's kind of like this. You got your select segment with the variable in there, and then in your language, there's going to be a method to bind a parameter where you reference the name, ID, and then whatever the dynamic variable, right? With this, it does not matter what kind of junk they put in the variable, you will not get owned if you're using a prepared statement, okay? All right, so that was for straight SQL injection. Anybody here uses an ORM entity framework? Hibernate, okay? So you can get injected with ORMs. So there is one documented case for Hibernate that was captured in this on the Matter site. And because it uses a query language that's the same at what in PHP they use with the doctrine ORM, the vector would probably be the same. But it's documented here. I recommend reading it. But to dig deeper into ORM SQL injections, there are two prevalent types of ORM. There are active record ORMs. So in Ruby, you got literally, it's called active record. In PHP, you have the eloquent ORM. And then you also have data mapper ORMs. So like the Java Persistence API defines a data mapper spec. Hibernate implements it. So nhibernate in .NET also uses the same thing. It's the same API. And then in PHP, there's the doctrine ORM. Okay, so now let's look at data mapper ORMs and how you can get owned on those. So some of them support a query string language, right? And where things get bad is when you can, again, it's adding a variable inside a string. So here's the basic string where destination ID equals, and then I concatenate a destination ID as a variable after that, right? Even though it's ORM, if somebody is crafty enough, you could actually turn that into an exploitable SQL statement. Now, if you're using HQL, the right way to do this is, again, to bind a parameter. And instead of comparing IDs like I do here, you can actually compare entire objects, right? And behind the scenes, it will compare the IDs, right? That's the nice thing about using an ORM. You can compare things at a higher level, right? We can actually compare objects with one another. So there's that. Okay, all right. Now, if you're using Entity Framework, I have a link to this article from Microsoft. From what I've seen so far, if you are using Entity Framework and you're doing queries with LINQ, you're going to be okay, right? Because LINQ does not use strings to make the queries, so you should be good. But Microsoft has documented some other pitfalls in other areas, so I highly recommend this article. Okay, so now let's go into Active Record. So in Active Records ORM, some of them have things called raw methods, where it allows you to instead of using their query builder, it allows you to kind of have a string. And again, it's the same thing, right? If you add a variable inside of a string, then you could get owned. So a good way to do it is to use their query builder. Avoid doing this, do this. Okay. And if you're working with Rails, there's a whole site dedicated to SQL injection vulnerabilities for Rails. So check it out and spend hours on this. It's a lot of fun. Okay. All right, so yeah, ORMs do provide an expressive vocabulary. They make the safe way convenient, and that's good. But of course, you can and you will still get owned if you don't use them as intended. I mean, that's, that. Okay, so that was for SQL injection. Now let's look at our friend NoSQL. Because if you're using MongoDB, well, you also have to pay attention to things. So OWASP has a whole set of articles on this. So please read them. And the way it looks like, it's a little bit like this, right? So you do a collection find, and you return, that's the expression that you search by, right? But now, instead of this 0 over here, we're going to put a variable that's user input. Well, some people found out that if, as user input, you pass this string here, you could cause 100% CPU usage for 10 seconds on your MongoDB database, and take it down for 10 seconds. So that's for denial of service, but there's also ways to leak data, right? So it's worth researching. To mitigate it, from what I've read so far, people seem to recommend to cast query arguments to string, and it should be okay. So you kind of go like this if you query by username, or if you query by password, but please don't query by password, like, ever. Just don't do that. I saw this as an example. I was like, okay, yeah, not good. All right, so that was for injections. Now let's look at cross-site scripting. I mean, this one's pretty simple. But you can steal credentials, do unauthorized operations, you can leak data, you can hijack sessions with that. And the vector is pretty simple, right? Reflected, it means you put something in the query string, and then the HTML page says, here are your results, right? It does not do any querying. It's like, please own me, right? So anytime you see a new search engine, that's the first thing we try, right? Stored means that you're going to save whatever was posted to the database, and you're not going to do any filtering. And then when you show the form, again, when you show the HTML, you're just going to display it without any kind of filtering, right? So to mitigate it, I like to look at two things. One is try to mitigate things when we save data, to try to get rid of nefarious things, right? But to me, the most important thing, though, is when rendering, right? Because even if we think that we filtered things when we save data, we can never be 100% sure that what we are retrieving from the database is actually safe, right? So we need to always be handling things at the rendering layer, right? Which is going to be the focus of the next few slides. So rendering HTML page. So read this. We're going to do a TLDR, but seriously, read this. A lot of really good stuff in there. But one of the things they're saying is try to not put dynamic data inside of a script block, because it's really difficult to escape. Same thing as an HTML comment, HTML attribute name, and the HTML tag name, CSS blocks. You really, unless you're building an HTML editor, right, you're probably never going to do these things, right? But if you are building like a CMS, yeah, you might be doing these things, and you may have to be very, very careful there, okay? Now, if you output JSON, right, let's say you're outputting some API, okay, like some RESTful JSON, Be careful with your content type header, because if you because when I output JSON in my API, I like to look at it in my browser, right, just so I can look at it. Well, if the content type is text HTML, my browser is going to think that it's HTML. So if my JSON has some script tag in there, it's actually going to boop, it's going to pop, right? If it's JSON that you're outputting, just set the content type to the proper MIME type. That's it. Okay, just a small thing, but very important. All right. So, aside from that, when you are inside of the HTML document, whenever you render data that came from the server, HTML escape it with HTML entities. If you are outputting a JSON blob, right? Let's say you want to initialize a React component and you want to have some JSON data in the body of your HTML. Try using Yahoo's JavaScript serializer. Okay. And then, if it's a URL fragment, just use URL escaping. Okay, so that was for rendering. Now let's get back to saving data. So when saving data, I just want to try to remove things that should not be there. I want to avoid doing too much escaping because I run the risk of doing double escaping when I render as well, right? So what I'll probably do is I'll just delete things that should not be there, like I'll get rid of all HTML tags, right? If I'm not building a CMS, then I shouldn't really have any HTML tags in there, so I'll remove them. But also try to have the proper data types, right? If it's a number, don't store it as a varchar, okay? Store it as a number, int, long, whatever, right? Because sometimes, I see things like, 10px being stored as a varchar. I'm like, oh, come on, just have a field that's an integer, and then reference a unit that's, in the lookup table, and normalize your schema, right? So, and like I said, if you're going to do any kind of escaping or encoding, you should try to just leave that to the rendering, right? So when you save data, get rid of bad things, and then when you render data, just escape things. Okay, so that was for cross-site scripting. Now we're going to look at cross-site request forgery. So this one is pretty fun. Do any of you remember back when social bookmarks were fun, like delicious bookmarks, things like that? Okay. Yeah. Back in the day, there were a lot of sites that allowed you to save bookmarks with a favlet on your browser and then share that with your friends, so your friends could see all your bookmarks. And then they, ranked the top save sites and all that stuff. Nobody does that anymore because it's all about Instagram, but back in the day, that's kind of how we shared things with people. So I'm using that as an example because we're going to see the example. But so the impact are unauthorized operations. In the vectors, it's unprotected transactional operations. So let me illustrate this. So let's say I am the victim site, and I have a form to post a bookmark, right? So I have a user registered on my site, and they're going to add a bookmark to their bookmarks. So that's what a form could look like. You get the bookmark title, the bookmark URL, and then you hit submit, and it submits to bookmark/add. Pretty simple, right? Now, I'm an evil hacker person, and I'm going to try to attract people to my site, attackersite.com. There are different ways I can do that, through an email campaign or whatever. And on my site, I'm going to have a hidden form. And my form's action is going to be the victim site. I'm going to put the bookmark title and URL as hidden fields. And then I'm going to use JavaScript to submit the form dynamically, right? Which means whenever somebody visits my site, I am adding my site to their bookmark. Why would you do that? Well, it's just to illustrate an example of what you could do, okay? And so that's cross-site request forgery, right? Because the end user is always going to be logged in on victimsite.com, right? So when they visit attacker side, and attacker side just kind of submits. Attacker side cannot read the website, but it knows what the form looks like, so it's going to make the user's browser submit a request to the site on its behalf without the user knowing, right? Some fun I had in the past was to add an item in somebody's Amazon shopping cart. You know, that's less innocent. So you can, to mitigate it, this is where CSRF token comes in. Pretty much every framework out there has a way to generate CSRF tokens. And it works usually when you leverage your framework's templating engine to generate a form. And then it will add the CSRF token automatically for you. And what it looks like is now this token is added to the form, and my server-side logic makes sure that the token exists and it's of the correct value. So the attacker side is not going to be able to guess what that token is, right? So they're not even going to try to submit it because they're not going to be able to guess it. So there are fun things that happen with CSRF. If you have a home router, some people got creative where they'll send a mass email to people with an image whose URL accesses the admin panel of your home router on your private network and adds a DMZ host so that then your network becomes wide open, right? There used to be some really badly written home routers with admin interfaces that allowed you to do that. So yeah, I won't get into that. All right, so that was low-level vulnerabilities. Now let's look at higher-level application vulnerabilities. We're going to look at three things: user authentication, OAuth Security, access control, and multi-tenancy. So let's look at user authentication. Did any of you attend Brock and Dominic's talk on OAuth? Okay. If you're using the Microsoft Identity Framework, a lot of these things will be taken care of for you. And many frameworks allow you to do that as well. But we're going to look at some common concerns. So user authentication, I recommend this URL. But we're going to look at a bunch of concerns: failure messaging, failure handling, multi-factor authentication, account recovery, password policies, password hashing, password transport, session duration and re-authentication, and finally, what happens when you have a compromised account. Okay, ready? Failure messaging, you want to avoid, when somebody fails at a login, you don't want to tell them too much, because then it gives them intelligence as to who exists on your site. Okay, so you don't want to say wrong password. It's like, hey, you gave me the right username, but that password is not quite good, okay? Just find the right one. Wrong user ID, so then that tells the hacker that that user does not exist on the site. Account disabled, that's also bad. This user is not active. It exists, but it's not active. You want to avoid these things. And it's not always practical. Sometimes for usability reasons, you kind of want to do that, but it's generally not recommended. So you want to keep things vague, and that's why on many sites you just see a vague message: login failed, invalid user ID or password. So that's good because it's vague. All right, next topic: failure handling. You want to mitigate brute force login attempts, right? So if you fail logging in against a specific username a given amount of times, then put them in jail for, I don't know, a couple hours. You could try limiting failures by IP address, but that's a good way to alienate people who all work in the same office, so just it's not great. You could also try to put CAPTCHA on your login form, but again, people are going to hate you very much. So I don't recommend it, but sometimes people do it. And you do want to log all failures, right? Attempted user ID, timestamp, IP address. You may also consider logging successful logins in case a user account gets compromised. And then you want to start tracking what happened, right? Multi-factor authentication. Here's a cheat sheet. No, that's an article on that. I use SMS a lot on sites to do, but I also know that phones do get lost or stolen. SIMs get cloned, right? It's unfortunate. So I also like to not disclose my site in the SMS verification. So if somebody's phone gets stolen and they see those text messages that says, oh, here's your password for mysite.com, right? Don't say what your site is to not give them any ideas, right? Now, account recovery. I've lost my password. It's gone. So security questions are a thing. Here I have a link to best practices for security questions. I like to treat those as passwords, but a lot of times they get stored in clear text. I don't like that. So on that link, you'll see better practices for that. One way to do it is an email with a one-time reset token. That's fine. Just try to not let that URL reset linger. Right? What I like to do is, right after I reset, I redirect to another page so the URL does not linger, because that URL can appear in the refer headers if somebody clicks away from your site, and somebody can try to get an idea and hijack your reset URL. So I recommend not letting it linger. Try to expire the token pretty quickly. But also remember that email accounts do get compromised, and there's not much you can do around that. Hope you have good security questions, but one-time code over SMS also works, but again, SMS does get stolen. So regardless of all these limitations, when you do reset somebody's password, remember to invalidate all existing sessions. Okay? All right, now let's look at password policies. One of the things you may want to do is prevent users from entering a password that is already documented. So it turns out there are lists of known passwords out there. There are small lists and there are big lists. So I have links to lists by Daniel Miessler on his GitHub. He's got lists of like hundreds of thousands of known passwords. It would be a good idea because those are passwords that have been compromised already, so you don't want people to reuse those passwords on your site. A good practice is to forbid a user from using one of their last 5 passwords. So, you kind of have to store the historical hashes for all those older passwords. Password length these days is 10 characters or more. It cannot contain the username. And it's got to have at least 3 of the 4 available character types, which would be lowercase, uppercase, numbers, and symbols. So 3 of those 4. And you might consider making users change passwords every 3 months. All right, so now let's look at hashing. I wish I could do a whole session on hashing, but I'm going to fly through this one real quick, right? So the whole point of password hashing is you can assume that your database has been stolen, right? And if it has been stolen, can the hacker guess those passwords? And if you got a good hashing framework, then it's not going to be an issue. So don't use a one-pass hashing algorithm. Don't just MD5 the password. Don't just SHA-512 the password. Use a hashing framework. And a hashing framework has features. These features are multi-pass, right? So it'll do hundreds of thousands of passes, which will tax the CPU, and it will also tax the memory, ideally. So if a hacker gets your database, it's going to take them like 1 million years worth of computing power to try to brute force guess what the actual passwords are for your users. They should have a unique salt baked into the hash. And so I've been using bcrypt. I still use bcrypt on most of my applications, but when I put this talk together, I learned that there's another hot algorithm out there that's a couple of years old. It's called Argon 2, and it won a password hashing competition. And so more and more authentication frameworks are starting to adopt Argon 2 for hashing. And there's a good comparison of Argon 2 versus bcrypt here by David Whitlock, so you can read that. If you're on the mean stack, I have a link here to make sure that if you follow this article, you'll be doing this with your passwords. All right, now password transport over the network. Obviously use TLS for everything if you can, right? Let's Encrypt.org makes TLS free. You know, SSL certs, basically, it's, you know, TLS. So definitely have TLS for login and registration and password recovery and all that stuff. Now, one thing I have tinkered with, do any of you remember Heartbleed? A few of you? So, wherever HTTPS or TLS is used on the internet, there is an open source library called OpenSSL. OpenSSL is used by the vast majority of any software that does any kind of encryption, okay? And there was a more than a decade-old vulnerability that was found a few years ago that was called Heartbleed, which allowed you to compromise encrypted traffic. And that means that literally TLS was not working technically for a bunch of years. So I've started playing with a client-side JavaScript encryption library where you can do public and private encryption. And if you combine that with TLS, then you will get the odds of your getting owned go a lot lower because both TLS and that library have to be vulnerable at the same time, right? And it's unlikely to happen. So I'm going to skip over this. You know, try to not have sessions last too long. And then if you do something more sensitive, ask for the password again. So if an account has been compromised, you know, consider having good logging throughout your application. It could be an event log with separate credentials. You can scale it independently, like in a NoSQL architecture if you want. Try to gather as much forensic evidence as possible. All right, here's a puppy. That's my dog, Archer. Okay, so let's look at OAuth Security. That could be its own talk, but I'm going to fly through it. So authentication. When you look at OAuth, there are two aspects of it. There's authentication and authorization. OAuth 2 focused on authorization, and it lacked authentication and some other specifics. So OpenID Connect came about, and it acted as a specialization of it to add the missing pieces, like authentication and more things. So anytime you're using some kind of API, social media sites, you know, log in with Google, they're using OIDC. Yeah. So it supports 4 grant types. There's auth code, there's implicit, there's resource owner password, and there's client credentials. We're only going to look at implicit. And implicit is used by most web applications. Like if you're doing a RESTful API or GraphQL API, you're probably going to be using the implicit grant. And what I like about it is that the user's login and password does not have to be persisted on your single-page app or inside of your phone app. And the flow for implicit is pretty simple. The user gets into the app, they're not logged in yet, so they get redirected to the OpenID Connect provider. Could be Google, right? Log in with Google. They're going to get that, you know, please log in, and then do you allow this application to do this, right? That's the page they're going to get. And then they're going to get redirected back to the app with a token. The app is going to use this token to send it to your API. And then your API is going to use a set of shared secrets to validate the token and make sure that it's correct. Okay, so these things in pink are basically your code. The OIDC provider, hopefully, is some third-party thing. It could live inside of your system, but it's like a well-tested OpenID Connect provider. So if you work with .NET or C#, use Identity Server 4 by Brock and Dominic, who are here at this conference, who gave a couple of talks, right? Definitely use that. Identity Server works really well, okay? So from a security standpoint, make sure you're using TLS for everything. There are a lot of redirection that's happening, so make sure that the URIs are registered for redirection. I have a link to ensuring proper token validation. If you're using JWT tokens, don't put sensitive information in there. And make sure you use well-tested library. Again, Identity Server 4 works great. All right, so now, resource access and multi-tenancy. So imagine, so this is documented here. You have a URI on your application that shows a user's report, right? What happens if I change the numbers and I mess with the URI, right? So I come across so many applications where we hide admin functionality, where we hide things. And all it takes is for somebody guessing the right URL to get access to things that they should not have access to, right? So it's a big problem out there. Some people like to use UUIDs to make the numbers non-guessable, but you're just obfuscating things and you're asking to be hacked, so don't do that. It's business logic, so make sure whoever's logged in has access to whatever they're supposed to do. Okay, and it's basically bad if a user can access another user's information. It's even worse when they can access users' information from another company in your system, right? If you have a SaaS application, you have multiple companies in there, and so you do want companies to see each other's information, right? But these vulnerabilities happen a lot, and it's pretty devastating. So that was for applications. Finally, some architectural considerations. Please secure your data stores, whether it's SQL or NoSQL. Please do not expose them to the internet. So many times I see people putting their MySQL or their MongoDB database on an open internet, and they can access it from their hotel room. Don't do that. Put them on a private network with a web server. Only the web server should be able to connect to your data store. Set those passwords. Apparently, people were firing up some MongoDB instances, and they were not saying any passwords. So they were open to the internet, and they did not have any passwords. So thousands of them got compromised. So I have an article here that documents that. Don't do that. Okay, then think about least privilege principle. If you have a database, like MySQL, you can set very granular permissions for users. You should not be able to drop tables in your web applications. So only give access to select, insert, and update. And ask yourself if you're even doing deletes, right? Often we do soft deletes. And if you still need to do deletes, can they be an offline process with a different user? You can create multiple users to lower the impact of an injection attempt. So you can have a read user that does selects, that's only allowed to do selects, and you can have a write user that can only do insert and updates, and maybe deletes. So if somebody compromises the read user, they're not going to be able to modify your data. And if somebody compromises your write user, they may not be able to exfiltrate your data. Okay, so that's a good way to mitigate the impact of things. I just want to look briefly at network and system design. So for each machine that you have on your network, you have an operating system. You have daemons that run on it, SSH, Nginx, Mongo, MySQL. You have frameworks that run on top of it. And then you have plugins. And then finally, you have your code, right? And anytime you have a machine that's exposed to the internet, the first thing hackers are going to do is they're going to try to do brute force credential attempts against your daemons, or do low-level like buffer overflow attempts. When they do that, then they get to own the operating system, and then they get to own your code, right? And then conversely, through OWASP vulnerability angles, they're going to kind of compromise these layers, which eventually will allow them to, in most cases, compromise the entire operating system. So you want to segment all the things. You want to reduce cross-contamination. So try to isolate each service onto its own machine. It can be a container, it can be a virtual machine, it can be actual hardware. Do not run unnecessary services. Make sure they're patched. You want to have strict network restrictions on cross-machine communications. They should only be able to communicate with one another on one port. For example, nothing can connect to the data store aside from the web server. Nothing can connect to the web server aside from the load balancer. Okay? So here's an example of a wildly insecure network. I have my data store on the open internet. I have a bunch of web servers on the open internet. And then I'm going to put a load balancer in front of it all. And then I'm going to do another application with the exact same setup, right? Hackers are going to look at this setup, and they're going to be like, hey, cool load balancer. I'm going to go ahead and ignore it. Boom, right? They're going to go around your load balancer, and they're going to try to compromise every single machine on your stack, right? A more secure approach is you have your cloud, and inside of your cloud you have a network for your first application, a network for your second application. You can put a data store in there with web servers, another one for the other application. So they're on their own separate networks. So if they breach here, they cannot go here. And then I'm going to put a load balancer. And my load balancer is going to be the only outward open access into my network. And then I'm going to put a firewall in front of my data store, and then a firewall in front of my web server. So basically, through this, I make sure that only the web server can connect to the data store, and then only the load balancer can connect to the web server. I may create a couple of VPNs such that DevOps can go in and manage this infrastructure. And then now attackers really don't have anywhere to go, right? Attackers cannot access any of this infrastructure. The only thing they can do is connect to your network through the load balancer. That's it, okay? So this is very trivial to do in any cloud hosting environment, whether it's Azure or Google Cloud or AWS. It's very trivial to do, so please do that. So I went over the benefits. That's fine. Last topic, securing credentials. Please don't check your credentials into your Git repo, right? It will take seconds between the moment you check your AWS key into GitHub and for a bunch of Bitcoin mining instances to be spawned at a very high cost to you. So don't put your database credentials into your Git. Don't put your AWS keys. Don't put any kind of third-party API credentials into your code repo. You might look at .env files. They are set up for PHP, Node, and Ruby, and I'm sure many other things. It's just a separate way to store the sensitive data. If you're using Ansible, there's Ansible Vault. That's pretty cool. You can actually encrypt things, which you could then check into your repository. Just don't store the encryption keys in there. But all right, so that was it. In the end, InfoSec is a mindset. It's our collective responsibility. It's not DevOps, it's not DevSecOps, it's all of us. It's executives, it's managers, it's software engineers, it's DevOps engineers. We all need to care a lot about InfoSec. I recommend subscribing to InfoSec mailing lists. These are the few of the ones to which I'm subscribed. And then when someone gets owned, let's not laugh at them, okay, because it could be us tomorrow. So the best thing we can do is read their case studies and find what's applicable to us. Okay, that's all I had. Here are the slides. Thank you very much. I'll be on the slide for questions. I don't want to hold you back more. Thank you.